Question 1. Which of the following oxides reacts only with HCl? So first we need to know that HCl is a strong acid, and the only oxide that will react with the HCl are the basic oxides, which are the metallic oxides. So for the first one, sulfur dioxide is an acidic oxide. It won't work as it's not a basic oxide. This one is a neutral oxide. This one is an acidic oxide. This is a basic oxide, so it's going to react only with the HCl. ZNO is an amphoteric oxide. It's going to react with HCl, which is an acid, and it's also going to react with bases. So the only correct option is the magnesium oxide. Which of the following oxides reacts only with the NaOH, which is sodium hydroxide? Now, NaOH is a very strong base, and only acidic oxides are going to react with it. So for the first one, this oxide N2O is neutral. It doesn't react with acids nor bases, so this is incorrect. The CO2 is an acidic oxide. It will react with NaOH. This is an amphoteric oxide. It will react with acids and with the NaOH. So this one is wrong. SO2 is an acidic oxide, so it will only react with the NaOH, so this is correct. MgO is a basic oxide, so it won't react with a strong base like NaOH. Which of the following oxide reacts with both HCl and NaOH? Now this one should be an amphoteric oxide to react with the acid HCl and with the strong base NaOH. So the only amphoteric oxide is ZNO, so this is the only correct option. Which of the following oxides neither reacts with HCl nor with NaOH? So it doesn't react neither with an acid nor with a base. So this oxide should be a neutral oxide. So the only neutral oxide among the list is the N2O. This is the only neutral oxide that will not react with HCl nor with the NaOH. Question 2. Which of the following reagents can be added to hydrochloric acid? And we need to know that hydrochloric acid is a strong acid to prepare zinc chloride. Now zinc chloride is the salt, and to prepare this zinc chloride, we need to react the strong acid with a zinc containing substance. Now we need to know to do this, we need the acid, which is the HCl, and we need a metal, like for example, let's say zinc, or we need, let's say, a metal oxide, or a metal hydroxide, or we need a metal carbonate. And by hydroxide or oxide, we mean it's O2 minus, hydroxide is OH minus, and the carbonate is CO3 2 minus. So for the first one, the zinc sulfate is not among the options we mentioned, metal oxide, metal hydroxide, or metal carbonate. Metal sulfates are generally not reactive with acids, so this is going to be wrong. Now ZnCO3 is a metal carbonate, so it's going to work. The zinc oxide is a metal oxide, so it's going to work. And zinc, which is a reactive metal, it will react with the HCl to give the salt Zn zinc chloride. So this is also going to be correct. So these are the correct options. Now, which of the following reagents can be added to sulfuric acid, H2SO4? And we need to know H2SO4 is a strong acid to prepare the copper sulfate. Now, to prepare copper sulfate, this is a salt, we need to react the H2SO4, this acid, this strong acid, with a copper containing substance. So we need an acid or excess of a solid metal, metal oxide, metal hydroxide, or metal carbonate. This was a metal oxide, CuO, so it's going to work. CuOH2 is a metal hydroxide, so it's going to work. CuCO3 is a metal carbonate, so yes, it's going to work. Cu is a metal, but it's not going to work in this case because Cu is unreactive with acid. It is unreactive. It has the low reactivity with acids, and we need to memorize the list in which we have metals that do not react with acids. These metals include the copper, the silver, the gold, and platinum. So these metals are unreactive with acid and we should be familiar with. Now question 3. Which of the following reactions produce ammonia gas? So we need to look at this list. For the first one, acid and metal carbonate, and carbonate ion, we mean CO3 2 minus. This is going to produce carbon dioxide gas, so this is wrong. Strong acid and strong base, let's say HCl, for example, plus NaOH. If they react together, they're going to give, let's say, a salt as NaCl and water. And there's not going to be any gas formed. So there is no gas formed. No gas produced from a strong acid and strong base, only salt and water, so this is wrong. Acid and metal sulfide, sulfide we mean the S2 minus, and this produces the hydrogen sulfide gas, which is H2S, that smells like rotten eggs, so it's not going to produce ammonia, so this is also wrong. The acid plus metal, let's say, of course it needs to be a reactive metal, not like the metals that we mentioned before. It could be, for example, zinc or iron, and this is going to produce hydrogen gas, not the ammonia gas, so this is wrong. Now the ammonium salt and the base, if we react an ammonium salt, let's say NH4Cl, with a specific base like NaOH, then it's going to produce the ammonia gas, NH3, so this is the only correct option. Question 4. During the preparation of silver iodide, AgI, by precipitation, what is the correct order of the steps? So AgI is an insoluble salt, and we need to use the precipitation method. So we need to order these steps. So first, when we are preparing the silver iodide, we need to mix two solutions. For example, let's say Ki and plus the AgNO3. So we need to mix them together to get the AgI. So the first step will be mixing. Then we need to stir to ensure the complete mixing is done. Then we need to perform filtration to get the filtrate and the residue will be the AgI. And after getting the residue, we need to dry this residue to let the water evaporate. So the correct ordering of the step is mixing, stirring, and then filtration, and then drying the residue in an oven. Question 5. Which of the following reactions produces a pungent smelling gas that turns damp red litmus blue? So this pungent smelling gas is the NH3 gas. It's called ammonia. And ammonia gas has this pungent smell. For the first reaction, CaO plus H2SO4, this is a reaction of a basic oxide and an acid. This is a strong acid. This is a basic oxide. As you can see, Ca is a metal, so it's a metallic oxide. And in this reaction, no gas is produced, only salt and water is produced. For the second one, we have a metal hydroxide. This is a base, and this is an acid. And when these react together, no gas is going to be produced, only salt and water. CaSO4 is the salt, and the H2O is water. Now for the third one, we have a metal, which is Ca, and we have the acid, which is H2SO4. And when we react a metal and an acid, hydrogen gas is going to be formed, not ammonia. So this is also false. For this one, when we react a metal hydroxide, a base, with an ammonium salt, we're going to get the ammonia gas, which is NH3. So this is correct. For the last one, when we have the carbonate ion, calcium carbonate, and we have an acid, then the gas produced is going to be CO2. So the only one that is correct is this one. And we need to remember that when we have a metal hydroxide, a base, a metal hydroxide with an acid, no gas is produced. However, when we have a base, a metal hydroxide with an ammonium salt, then ammonia gas is going to be produced. So this is the correct answer. Now for question 6, which of the following reactions produce a gas? For the first one, strong acid and strong base, no gas is released, only salt and water are going to be formed when you mix strong acid and strong base. Let's say if we mix HCl and NaOH, we're going to get the salt NaCl and H2O. No gas is going to be produced. For this one, we will have hydrogen gas, so this is the correct option. For the third one, where we have acid and metal oxide, no gas is going to be formed. For an ammonium salt and a base, we're going to have ammonia gas, and we mentioned this before, so this is also a correct option. And for the acid and metal carbonate, this is also correct, as carbon dioxide gas is going to be formed. For the last one, the acid and metal sulfate, this is also correct, as we're going to have the sulfur dioxide gas, and this is a choking gas, the SO2. And if acid and metal sulfide was also an option, it would also be correct, as the hydrogen sulfide gas would be produced, which is H2S. Now for question 7, what are the pieces of apparatus needed during the preparation of sodium chloride NaCl by titration? So let's first explain what is titration, or what's the setup that's needed for titration. So this is the setup that we need for titration, and titration is a lab technique in which we add a solution of known concentration to a solution of an unknown concentration, and we use titration to determine the concentration of the unknown solution. So we place the acid mainly, let's say, in the burette, and we place a base in the conical flask, and we use a dropper to put some indicator. Now the indicator will change color when the reaction is complete. So we are able to observe or to detect when the reaction is complete by the color change that's placed, for example, in the conical flask, and the acid will be added progressively and slowly to the base. Now we might need also a pipette to prepare the accurate volumes that will be placed in the burette and in the conical flask. So for question 7, the pieces of apparatus that we will need to prepare NaCl. Now I just would say that, for example, NaCl is the salt, and it would be prepared, for example, from the base, strong base NaOH, and from the acid HCl. So we are going to need a pipette to measure a fixed volume. We're going to need the burette for titration to deliver the solution slowly and accurately. A balance is not needed in titration unless we are preparing solid reagents, unless if we want to measure the mass of the solid, but it's not needed. It's not, for example, really important if we're using a solution. The conical flask will be needed to hold the solution during the titration, as we saw in the setup. And we might need, for example, a beaker instead of the conical flask. A beaker will also hold the solution. So if you look at the options, for the first one, the balance is not always needed. The pipette will be required and the burette will be required. For the second one, they placed a stop clock, but time measurement is not required in titration. We don't need to measure the time. So this is not needed. This is needed. A dropper will be needed to add few drops of the indicator. Over here we still have the balance. The balance is not always needed. Over here we have the stop clock and we have the balance, so these two are not needed. This is the only option in which we have all the apparatus that we are going to use for titration: the conical flask, the burette, and the pipette. So this is the correct answer. Now for question 8, dilute sulfuric acid, and dilute sulfuric acid is H2SO4, is added to a mixture that contains magnesium, zinc, and copper in a beaker. The beaker is left for about 15 minutes and its contents are then filtered. What does the filtrate contain? So if you look at Cu, zinc, and Mg, Cu first is a metal, but it will not react with the acid, which is H2SO4, because Cu is an unreactive metal. If you want to say, it has a low reactivity with the acid. So Cu will remain and nothing is going to be formed, either copper sulfate nor copper 1 sulfate. So these two are going to be eliminated. Now zinc and Mg will react with the H2SO4, and they will react in this way to give magnesium sulfate and zinc sulfate. So these two options are correct, as zinc and Mg are the only metals that will react with H2SO4 and form a new substance. For question 9, some reactions of substance M are shown below. Substance M reacts with magnesium to give hydrogen gas, reacts with sodium carbonate to give carbon dioxide gas, reacts with copper 2 oxide to give copper 2 chloride. So something that will react with a metal and will give hydrogen gas is an acid. An acid reacts with metal and it will give a hydrogen gas. The metal is magnesium. An acid will react with sodium carbonate, and carbonate is CO3 2 minus. And when an acid reacts with a metal carbonate, it's going to give carbon dioxide gas. So now we know that it's an acid. Now, if it reacts with the copper 2 oxide, copper 2 oxide is a basic oxide, and when an acid reacts with the basic oxide, it's going to form salt and it's going to form also water. So the salt that is formed is the copper 2 chloride. So in this case, the acid reacted with the basic oxide to give a copper containing salt, and this salt also contains the chloride, the Cl- ions. So they said choose the chemical formula of substance M. Now for H2SO4, it cannot be H2SO4. Even all of these are acids. We should only pick one. This is an acid, but the salt doesn't contain the SO4 minus at the end. The salt actually contained the Cl minus, it contained the copper chloride. So it's not H2SO4 as it doesn't contain SO4 minus. It's not HNO3 as the salt doesn't contain NO3 minus ions. It is HCl as Cl is made up of Cl minus and H plus, and the salt contained Cl minus ions, which indicate that the reaction taking place over here is HCl plus the copper oxide to give the CuCl2 plus the H2O, and we need to put 2 before the HCl. So the salt that was formed is CuCl2. It contained the Cl minus ion, which indicate that the acid used was HCl. Question 10. The information in the box is about the preparation of magnesium nitrate crystals. So we have steps, and magnesium nitrate has this formula. It's made up of Mg2 plus and the NO3 minus ions. And they said that they add the spatula measures of magnesium oxide. Now magnesium oxide is the basic oxide to some hot dilute nitric acid, and nitric acid is the HNO3, and nitric acid is a strong acid. We have step 2, continue adding magnesium oxide, remove the excess magnesium oxide, evaporate the magnesium nitrate solution, leave the saturated solution to cool, and then remove the crystals and dry the crystals. The first question was, identify among the following the reason excess magnesium oxide. Why did we use the magnesium oxide, which is the basic oxide, in excess? For the first one, it was filtration. So we need to pick among these three options. Filtration. For filtration, MgO doesn't dissolve. It is insoluble in water. And when we use filtration, MgO will be our residue. So filtration will separate the base, magnesium oxide, and the salt, magnesium nitrate. So this is a correct method that we can use to remove the excess magnesium oxide. Sublimation doesn't work as MgO doesn't undergo sublimation, doesn't go from solid to gas. Ammonium chloride and iodine, they actually sublime, and magnesium oxide is not a solid that will sublime, so therefore this is incorrect. Now crystallization, this is not used for removing excess solid, which is MgO over here. Crystallization is used usually after filtration to recover the dissolved salt by evaporating the water. So crystallization is mainly used to evaporate the water and not to remove the excess solid. We use filtration to get it as a residue on the filter paper, and then we can separate the salt and the basic oxide, which is MgO, and the salt, which is magnesium nitrate. Which of the following is a method to show that the solution is saturated? And by saturated, we mean that the solution cannot dissolve any more solute. The first option was dip a cold glass rod from time to time in the solution to check the formation of crystals on the tip of the rod. So if the glass rod is cold, then we will have a small decrease in temperature, and this small decrease in temperature will cause the excess solute to crystallize. We're going to see crystals on the tip of the glass rod. As we know that when temperature decreases, the solubility is going to decrease. So we're going to see some crystals forming on the glass rod. Now dip a wet litmus paper in the solution and wait until the paper bleaches. This is actually used to detect chlorine gas, and it's not saturation of a solution. Pass lime water over a sample of the solution and wait until lime water turns milky. This is actually a test for carbon dioxide gas, and it's not a test for the saturation of a solution. So the only correct answer is this one, as we're going to see some crystals forming on the glass rod. Why the crystals in step 7 are dried using filter paper and not by heating? So we usually dry the crystals using filter paper, and we do not heat them. So the first option was to get large crystals. Now we need to know that drying the crystal doesn't affect the size of the crystal, so this is wrong. To prevent the breakdown of the crystals, this is correct, as heating can cause some crystals to lose water and break down or decompose. This could damage the crystal structure, especially when we're talking about the hydrated salts. So hydrated salts have water in their structure, contain water molecules as part of their structure. So if we heat it a lot, we can break down the crystal. So this is correct. To prevent the loss of water, as we mentioned over here, some salts like the hydrated salts, they contain water molecules as part of their crystal structure. So we shouldn't let this water to be lost. So because this water preserves the correct form of the crystals. As we said, some salts are naturally hydrated. Example, the copper sulfate, CuSO4 5H2O. It has water molecules in it. So therefore, to prevent the loss of water is correct because it preserves the correct form of crystals. To prevent the formation of powder, this is also correct because heating causes the crystals to become dry too fast or to even crack, turning them to powdery fragments. So we shouldn't be heating to prevent breakdown, to prevent the loss of water, and to prevent the formation of powder, as heating causes the crystals to become dry very fast and even crack. Question 11. Suppose that 0.1 mole of solid NaOH, this is a strong base, is added to 0.2 liters of 2mHCl, which is a strong acid. How many more moles of HCl are present in the solution than the moles of NaOH? So first I've found the moles for the NaOH is given as 0.1, and of HCl is C times V, 2 times 0.2, and the answer is 0.4. Then I subtracted to get the extra moles for HCl, which are 0.3 mole. So how many moles of HCl are present? Then the moles, it will be 0.3 mole of HCl. From the excess number of moles and the volume, calculate the concentration of excess H plus, and we need to give our answer to three significant figures. So HCl, first of all, is a strong acid. It dissociates completely. So we can write the equation this way, as the moles of HCl will be equal to the moles of H plus, which is 0.3. Then I'm going to use this formula, which is the concentration of H plus is equal to the number of moles over V total. The number of moles will be 0.3 and the V total is 0.2, and we're going to get the answer 1.50. This is to three significant figures. Then they asked us about the concentration of OH minus at equilibrium given the Kw, which is 1 times 10 minus 14 at 25 degrees Celsius. And usually this is the most common value that they will give you in the exam. So we have this formula that we need to memorize. We have the H plus that we calculated over here. Kw is given. Then we can use this equation to find OH minus. And it's going to be 6.66 times 10 to the power minus 15. Now question 12. For 100 milliliters of 1m NaOH is added to 200 milliliters of 2m HCl. What's the final concentration of H plus and OH minus? So first I need to change, let's change the volume to liters. This will be 0.4 liter. This is NaOH. It's a strong base, and it's being added to 0.2 liters of HCl, which is a strong acid. So step one, we're working to find the H plus and OH minus concentration. So let's first find the number of moles that we're using for the NaOH, which is the strong base, and the acid, which is HCl. I do C times V, I find the number of moles. As you can see, I have the same number of moles for NaOH and for HCl. So these two are going to react completely. So I'm going to write the net ionic equation and subtract to find the number of moles left. Now this is not needed, but I wrote it over here to show you that the number of moles will be the same. And then at the end, neither H plus nor OH minus will be in excess. So the concentration of H plus will be equal to the concentration of OH minus at the end. So we need to know that when we have equal amounts of HCl and NaOH react, equal number of moles, they completely neutralize each other. In this case, the H plus and the OH minus ions are both determined by the self-ionization of water, which is this equation. This indicates that the solution is neutral and neither the H plus nor the OH minus is in excess. In this case, the concentration of H plus and OH minus will be equal. So I will use this equation over here. The radical of 1 times 10 to the minus 14 will be 1 times 10 to the power minus 7. This represents the concentration of H plus, which will be equal to the concentration of OH minus. For question 13, calculate the concentration of hydrogen ions H plus in a 0.06 m aqueous solution of KOH. We need to know KOH is a strong base, so we're going to use one arrow as strong base or strong acid dissociates completely. So we need to find the concentration of H plus. First, let's find the OH minus, because KOH will give K plus and OH minus. Always remember that a base will give OH minus, and acid will release H plus ions in solution. So I wrote the equation over here. We have KOH will give K plus plus OH minus. We need to know that KOH will dissociate completely. So 0.06 m for KOH will give a 0.06 m OH minus. As you can see, the coefficient is 1 and 1. Then we write KW, and using KW we can find the H plus, which will be 1.66 times 10 to the power minus 13. Now they need the answer to two significant figures, and in scientific notation, so it's going to be 1.7. 6 greater than 5, so it's going to be 1.7 times 10 to the power minus 13 m. For question 14, a student wants to find the concentration of hydrogen ions H plus and hydroxide ions in a sample of 0.4 m strong acid H2A aqueous solution at 298 Kelvin. Calculate the OH minus and H plus. We have KW is 1 times 10 minus 14. We should memorize this value, as KW will always be 1 times 10 minus 14 at this temperature, or when they say 25 degrees Celsius. And they said give your answer to three significant figures. So first, we need to find the H plus. Now we need to know something, that H2A is a strong acid, and since it's a strong acid, we're going to use one arrow. However, in this case, I'm not going to form only one H plus. I'm going to form actually two H plus ions. So I need to consider that I need to place the coefficient 2 over here. So if this is 0.4, this is going to be 0.8, as we need to multiply the concentration by 2, as two acidic H plus will be released. So in this case, it will be 0.8. Then I will use the KW formula to get the OH minus, which will be 1.25 times 10 minus 14, and these are three significant figures. Question 15, a student is asked to find the pH of a solution. In an experiment, he prepares hydrochloric acid dissolving 0.08 mole of the acid in 250 milliliter volumetric flask. So it will be 0.25 liter. And they said calculate the concentration of the H plus in the solution. So first we have HCl, and HCl is a strong acid that produces H plus. It will dissociate completely to give the H plus ions. So let's find the concentration. It is 0.320 m, dividing N over the volume, which is 0.25. So this will be equal to the H plus, because HCl dissociates completely, and therefore the concentration of H plus is 0.320 m. Now, then they asked us to calculate the pH. The pH is minus log H plus, which will be minus log 0.320. It will be 0.4948. They need the answer to 3 decimal places. So 1, 2, 3. I need to round. It's going to be 0.495. Question 16. Calculate H plus and OH minus in 250 milliliter of a 0.4 m H2SO4, assuming acid is strong. The KW is given, and we need to give our answer for OH minus to, in scientific notation, to 3 significant figures. So first, I'm going to, since H2SO4 is a strong acid, then we need to remember also that it's going to give H plus and SO4 2 minus. However, it's going to give 2 H plus. So a common mistake is where students do not include the coefficient for H2SO4, that is actually 2. Now for HCl, it will be, for example, H plus and Cl minus. There's no need to put a 2 over here. We shouldn't put a 2. However, for H2SO4, 2 H plus ions will be released, so we need to put 2 over here. So if this is 0.4 m, this will be 2 times 0.4, which will be 0.8 m for the H plus. This acids release H plus. If H plus is 0.8 m, then the OH minus is going to be KW over H plus. It will be 1.25 times 10 to the power minus 14. So question 17, they're telling me 3 methods are used for salt preparation. Method A, using a burette and an indicator. And we mean by this, it's a titration method. And titration method is used actually for soluble salts. Now the soluble salts need to contain Na+, K+, Li+, or the ammonium NH4+ ion. Method B is done when we mix 2 solutions to obtain a salt by precipitation, and this is actually used for insoluble salt. Method C is the addition of excess base or metal to a dilute acid. We refer to this as the excess method, and it is used for soluble salt. These soluble salts do not contain Na+, K+, Li+, or NH4+. So they said identify the method used to prepare soluble salt magnesium chloride from the insoluble base magnesium oxide. So the salt over here, which is magnesium chloride, which is MgCl2, doesn't contain Li+, Na+, K+, NH4+, and it is soluble. Therefore, I'm not going to use titration. I will be using method C, which is the excess method over here. So it's used for soluble salts, and it's not used for salts that contain Na+, K+, Li+, or NH4+. So it will be this one, C. Choose the proper reagent to prepare the soluble salt magnesium chloride from the insoluble base magnesium oxide. Now we are going to need an acid to react with the base, which is going to be magnesium oxide. So among these options, the only acid is HCl. This is not an acid, it's a salt. Ammonia is a weak base, and H2O is not an acid. Now HCl is a strong acid, and it contains the Cl- ions, as they said that the salt that they wanted to be formed is the MgCl2. So HCl is the correct option, as it's an acid and it contains the Cl- ions, which will form the MgCl2. And the equation will be magnesium oxide reacting with HCl. Now the farthest ion with the farthest ion, so it's going to give the MgCl2, and these two, which will give the water, and we need to balance and put 2 over here as a coefficient. For the final question, question 18, we have 50 milliliters of a 0.2 m HCl is titrated by an NaOH solution. The endpoint is reached when 29 milliliters of the NaOH solution are added to the acid solution. What is the concentration of NaOH solution? So we're using a titration. The reaction taking place is NaOH is reacting with HCl. As you can see, we have Na+, Cl-. They will give the NaCl, and H+ and OH-, which will give water. This is a reaction between a strong base, which is NaOH, and a strong acid, which is HCl. Now they are reacting in 1:1 mole ratio. As you can see, the coefficient is 1:1. Now we need to know that at the end point, the number of moles of HCl divided by 1, as we're using the stoichiometric ratio, which is 1 over here and 1 over here. So the number of moles of HCl divided by 1 will be equal to the number of moles of NaOH divided by 1. This we refer to as stoichiometric ratio. Now I need to substitute. I have the concentration of HCl and the volume. So 50 times 0.2 over 1 will be equal to the concentration of NaOH multiplied by the volume, which is 29, divided by 1. And so the concentration will be 0.3448. They need the answer to 3 significant figures. So 1, 2, 3. So it's going to be 0.345 m. I just want to mention over here that the volume, I kept it in milliliter, and over here in milliliter. You can change it to liter. However, you're going to end up with the same answer, as they will be cancelled at the end. And the final answer will be 0.345 m. So if you use, for example, let's say over here 0.05, and over here use 0.029, you're going to end up with this with the same final answer.